Hey, it's T. I'm one of the geniuses at AskZylor. So let's just get started with the live session.
So we're going to go ahead and get started with the first question. So this question saying we have a 10 kilogram crate is pushed 10 meters up a ramp at an angle of 30 degrees. What is the work done by gravity? So we'll go ahead and draw a simple diagram just to show what we're dealing with. So we have a crate which is 10 kilograms, right? We have gravity acting downwards and we're pushing it up. So distance is up this way, and then we have an angle of 30 degrees. So what we're dealing with is a work problem. So work equation can be defined as force cross, the dot product of force and distance. So these are vectors, so we can simplify this to give me the magnitude of force times the magnitude of my distance times the cos of the angle between these two vectors. So this is the angle between the two vectors. I know this is 30 degrees, so how do I find this? I know this angle is going to be 90 degrees. So the difference between this vertical line here and this perpendicular line is going to be the 30 degrees, which is the incline. So I'm just going to add those two up to tell me what the total angle is. So my total angle is going to be 90 plus 30, so it's going to be 120 degrees. So I found my theta. It's 120. So the force given the force is going to be mass times gravity. That's how I get my force due to gravity. So I have a 10 kilogram multiplied by my force of gravity times 9.8 is going to give me 98. So I'm going to plug it back into my work equation. So work is equal to force, which is 98, times 10 meters times cos 120. So then I'm going to go ahead and plug all the values in to give me a negative 490 joules of work. So how much work does gravity do? So it does negative 490 joules. So this is more of a physics question, but we're using vectors to solve this. So you can encounter this when you're going through energy in the physics units, but vectors is good applications for this as well. So we had to find the work done by gravity, so we came up with a simple diagram that shows a box being pushed up. So my distance that's being pushed up is going to be up the slope, but my gravity is down. So I had to find the angle between these two vectors, so I realized I have a 90-degree angle and the remaining angle is simply the incline, so I added those up. And then work is the dot product of force times force and distance. So my force, I need to find what the value is, so I just found m mass times gravity, so 10 times 9.8 to give me 98. And then I plugged it into my work equation, and then my distance is 10 meters. All that is going to give me negative 490 joules. The negative is something to worry about if you're in physics. If you're taking vectors, you don't need to worry about the context of that. So we're going to go ahead to the next question that was sent in and go ahead and solve that. So this one tells me adventurer Carl wants to create a kite. To make it easier for him, he drew the kite on a Cartesian grid. The corners are located at 4 coordinate points. How much plastic sheeting should he prepare? So the shape kind of looks like a parallelogram, and we know that the area of a parallelogram can also be given by the cross product of two sides. So let's pick AB and AD. So my area is going to be the magnitude of this cross product. So I have AB cross with AD. And AB is going to be, I need to find that vector because I haven't been given that. So I'm gonna do B minus A essentially. So it's going to be 2 minus 2, 2 minus 0, and then 6 minus 3 from these 2 points. So this gives me 0, 2, and 3. I'm going to do the same thing for AD. So I have 2 minus 2, 2 minus 0, and 0 minus 3 from the A and D points. I'm going to go ahead and equal that to 0, 2 minus 3. So I've found my two vectors. I have A and I have D. I'm going to go ahead and find the cross product. So my cross product is going to be AB cross AD. So there's many ways that have been taught. So the way I know commonly is going to be, I just remember a pattern. It's going to be 2, 3, 3, 2, and then these just go up by 1. So 3, and then it goes back down to 1, and then either the first term, and then 1, 2, 2, 1. So I just know this pattern because I've done this many times. So an easy way to remember the cross product is I just need to know 2, 3. If I know 2, 3, I can come up with the rest of these numbers. So if I know 2, 3, to find my x coordinate, it's 2, 3 minus the opposite of 2, 3, which is going to be 3, 2. And to find my y, I take 2, 3, and I add 1 to each of these numbers. So if I add 1 to 2, I get 3. If I add 1 to 3, I get 4, but I only have 3 coordinates. I have the x, the y, and the z. So 1, 2, 3. If I can't really go above 3, so I drop back down to 1. So I get 3, 1 minus the opposite of 3, 1 is 1, 3. Then I do the same step. So I add 1 for 3 and 1, so which gives me 1, and 1 plus 1 is going to give me 2. The opposite of that is going to be 2 and 1. So that's how I remember cross product. So another thing to note is that each number is the position, the component of the first number is the position of the first vector, the second number is the position of the second vector. So if I have 0, 2, 3 as my first vector and 0, 2, negative 3 as my second vector, what's my cross product? I have 2 times negative 3 minus 3 times 2. That's my x. My y is going to be 0 times negative 3 minus 3 times 0. Then I have 0 times 4 minus 2 times 0. Sorry, 0 times 2. So all that is going to equal to 3 coordinates. This is going to be 2 times negative 3 is going to be negative 6. Negative 6 minus 6 is going to give me negative 12. 0 times anything is 0, then minus 0 times 3 is again going to be 0. So that's my y value, and then these two terms are again 0. So I have a cross product of negative 12, 0, and 0. So if we look back at our initial equation, it said area is the magnitude of this cross product, so I don't really care about the sign. I only have one value, so my area is going to be 12. It's going to be meters squared. We're just going to assume those are the units. So what did I do? I realized that I was given a parallelogram and I had to find the area of the parallelogram because they're asking how much plastic sheeting is needed. So I just used two adjacent sides to do the cross product. I picked AB and AD, and then I went ahead and found the vectors AB and AD and did the cross product for them. And I showed you a little trick to kind of do the cross product easily. And then I went ahead, plugged those numbers in, came up with a vector of -12, 0, 0, the magnitude of which is going to be just 12. So we'll go ahead and start the next question. It says, show that L1 and L2 describe the equation of the same line. So if they're the same line, that means we have to do two things. We need to find out that the slopes are the same, and we need to see if any of the 2 points given are a match on the other line. So we need to see what the direction vectors are and see if they have the same slope, and then pick one of these points and plug it into the other equation to see if it's actually in that line. So my direction vectors are -1 and 2, and then 3 and -6. That means these slopes have to be the same, or it needs to be a multiple of one or the other. So I'm just going to say k is some multiple. So what can k be to give me 3 and -6? So k could be -3. If I plug in -3 for k, I should get 3 and -6, which is the same as the other direction vector. So I know that these two slopes can be parallel. So I've done one check. So the next check is to see if there's a common point that exists in both the lines. So let's say I pick 3 and 7. I'm gonna get the parametric equations for the first line, so L1. So I have x is equal to 6 plus minus 1t, which is going to be 6 minus t, and then I have y is equal to 1 plus 2t. And then I'm going to plug in 3 and 7 into my x and y. So 3 is equal to 6 minus t, and -6 is equal to 1 plus 2t. And I need to check if the parameters are the same for my x and y. If they're the same, that means that point is on that line. And if that point is on that line, that means they're the same line because we already did the check that they have the same slope. So let's go ahead and solve this. I have t is equal to 3 in this one, and I should get t is equal to 3 in this one as well. Sorry, I was supposed to plug in 3 and 7. This is a different one. I'm just going to do 3, 7. So it's not really much different. I just need to plug in a 7 here, which is going to give me a t is equal to 3. So we still went through, and what were the steps? We went through and checked that our slopes were the same by seeing if there's some factor that's going to multiply one of the direction vectors to equal the other direction vector. Then I picked one of the points on one of the lines, and then I plugged those into the other line to see if that point exists in the other line. So we're going to go to the next question. So we have two perpendicular lines, L1 and L2. We have two equations, so find the value of k, then write the symmetric equation for L1. So two perpendicular lines, L1 and L2. We're given two vector equations, but in one of the direction vectors we have a k instead of a y value. So we should be using the information given to us pretty well, because the two perpendicular lines, L1 and L2, that's important, because what's the dot product of two perpendicular lines? It's going to be 0. So if I find the dot product of L1 and L2, it should give me 0. So I'm going to go ahead and do that. So I'm going to use the direction vectors as the vectors. So I have -2, k, 1, dot product of 4, 1, 3. It should give me 0. So -2 times 4 plus k times 1 plus 1 times 3 should equal 0. So I'm going to simplify this. This is -8 plus k plus 3 is equal to 0. In other words, k is equal to 5. So what we're doing is we're going through some vectors questions. We've solved part of it. We've found what k is. Find the value of k. We've done that. But they're saying write the symmetric equation for L1. So I'm going to rewrite the equation with my k. So I have L1 is equal to R1. I'm going to say that's my vector equation. That's equal to 7, 2, negative 1. I'm not changing any of the points. But instead of k, I'm going to write my new value for k. So I have negative 2, 5, and 1. The second part of the question says write symmetric equations for this line. So symmetric equations usually takes the form of x, y, z with a point on top and then the direction vector on the bottom. The component of the direction vector on the bottom. So for example, for this equation, what's my point for x? It's 7, so I'm going to write minus 7. My y is going to be minus 2, and my z is going to be minus 1, so minus 1 is going to be plus 1. My vector components for my x is going to be negative 2, that goes as the denominator, and then the y is going to be 5, the z is going to be 1. So this is how you write symmetric equations from a vector equation. I put the negative value of the point on top, and then I put the vector component, the component from the vector, the direction vector, as the denominator. Any questions about this? So once again, if you have any questions that you want us to solve, please send them in. We'll be happy to help you out. So we just went through, we just found the value of k because we knew perpendicular lines have a dot product of 0. Then we just found the dot product of those two vectors, plugged k back in, and found the symmetric equations. So let's go ahead and start the next question. So it's saying find the symmetric equation of a line containing the point 1, 2, 3. It has a direction vector 3, 0, 5. Use the symmetric equation to check if the line intersects with the y-axis. So we have a point, we have a direction vector. Let's go ahead and write symmetric equations. So I have x, this is a point, so I have x minus 1. What's my direction vector? 3 is equal to, I'm going to keep y for now, I'm going to jump to the z value. So I have z minus 3 over 5 is equal to y. So it should be y minus 2 over what's my direction component is going to be 0. It should be that, right? But it's not, because I can't really divide by a 0. So what I'm going to do instead is just put a comma, and I'm going to say if there's no direction component for my y, it's only going to be that point itself. So my y is always going to be equal to 2. So we're going to go ahead and jump to the next question. So it says find the value of p in the equation below if the line has an x-intercept at 2, 0, 0. So all we have to do is, we have a point, we have the symmetric equations, we're going to plug in each of these coordinates into our symmetric equations. So we have x minus p over 1, so my x value is going to be 2. I'm going to plug in 2 minus p over 1 is going to equal, my y value is going to be 0, so negative 4 over 2. Z is going to be 0, so negative 2 over 1. And then I need to try and solve to give me p. So I have 2 minus p is equal to negative 4 over 2 is going to give me negative 2. And negative 2 over 1 is going to give me negative 2 as well. So I can pick this, or I can pick these two to solve my p value. So I'm just going to go ahead and stick with the first two, so this, to go ahead and solve that. So I'm just going to do 2 minus p is equal to -2, so p is equal to 4. So the question was simply asking find the value of p in the equation below. So we were given the symmetric equation, so all I did was plug in the coordinate given to me into my symmetric equations. Used 2 of the equations, I didn't need to use all 3. And then find my p-value. I found that p was equal to 4. So this is a question sent in by a student. So we have, if a and b are unit vectors that make an angle of 60 degrees with each other, tail to tail, calculate 2a plus 3b. So let's go ahead and write this down. So we have a plus 3b squared. It's equal to 2a plus 3b. 2a plus 3b. So I got this because I know if I just have the magnitude of a vector, it's going to be the vector squared. Does that times that. So then all I'm going to do is just distribute each of these terms. So I have 4a squared and then I have 6ab plus 6ab, so I just have 12ab. I'm just going to write 12 plus 9b squared. Right, so both of these are unit vectors, right? So if I have what the magnitude of unit vectors are just going to be 1, right? So if I have 4 times the magnitude of unit vectors, it's just going to be 4. And this is going to be 9, right? So I only have 12a times b. So then I have 12a times a dot product of b. So the dot product is going to be the magnitudes of a, the magnitude of b times the cos theta of the angle between them. And we know the angle between them, right? It makes an angle of 60 degrees. So we're going to go ahead and plug those back into my original equation back here. And so this is simply going to be 1 times cos 60, which is going to give me 1/2. So then I have 4 plus 12 times 1/2 plus 9. So then I have 4 plus 6 plus 9, which is going to give me 19. Alright, so let's just recap what we did. So we had a and b, which are unit vectors that make an angle of 60 degrees with each other, tail to tail. So calculate 2a plus 3b and find the directional angle. So we needed to find the magnitude of this. So we know the magnitude of a vector is simply going to be the vectors, the dot product of 2 vectors, and we just expanded, distributed each of the terms. And then we know the unit vectors, so the magnitudes of each of them are just going to be 1. So the individual ones, I just kept them as the coefficients. And then 8 dot product of B, I expanded. I know the dot product of A and B are going to be the magnitudes of A and B times the cos of the angle between them. So the angle between them is 60, so I have half. So I plug that back into my original equation. So I have 4 plus 12 times half plus 9 to give me 19. And the angle is still going to be 60 degrees. So we went through some questions for vectors. We went through some questions that you guys sent in. We also picked some questions that you'll commonly see on a test. So if you have any questions, please send them in. We'll be doing a live session every week at least. And if you missed any of the live sessions, if you want to watch any of the questions being done, you can hit the link in our bio. It'll take you to the YouTube channel where you can see all our live recordings, and you can also find the questions still on our story. So we're just gonna sign out right now because we finished all our questions and there's no more questions being sent in. So this has been T from AskZylor. We are service dedicated to helping out students. If you have any questions that you want answered or done on live, send them in to our DMs and we'll be happy to help you. So until next week, I'll see you guys later. Take care.